Welcome. Guess what? Imagine a city where every delivery moves like clockwork. Every street flows like liquid light, and every vehicle knows its route before a human even thinks about it. In Durban, South Africa, neon reflections shimmer off wet asphalt as autonomous vans glide through crowded streets. AI algorithms constantly analyze traffic patterns, predicting congestion and rerouting vehicles instantly, transforming urban chaos into seamless efficiency. Picture Santiago, Chile. Morning rush hour usually means slow deliveries, frustrated drivers, and gridlocked streets. But with AI maps overlaying the city in real time, optimal paths for vans, bikes, and drones are calculated. Vehicles weave effortlessly through intersections. Pedestrians move naturally alongside glowing sidewalks, and every delivery reaches its destination faster than ever. In Tokyo, Japan, one of the densest cities on Earth, AI calculates split-second adjustments to every route. Autonomous robots move alongside pedestrians, bicycles, and taxis with uncanny precision. Neon signs flicker above, reflecting off wet streets as AI predicts human patterns, ensuring packages arrive safely and on schedule. Here, speed meets empathy and efficiency meets ethics. Stockholm, Sweden shows a different challenge. Quiet streets, environmental priorities, and sparse traffic. AI balances rapid delivery with sustainability, rerouting electric pods around congestion while reducing emissions. Neon indicators on vehicles communicate route changes seamlessly, merging futuristic aesthetics with human-centered logistics. Even serene cities thrive under AI-guided precision. Sydney, Australia, comes alive under sunset neon reflections across the harbor. Autonomous trucks calculate bridge congestion, ferry schedules, and optimal street routes. AI ensures that every delivery moves smoothly, minimizing delays and energy waste. Ethical decision-making is embedded too. If a pedestrian suddenly crosses, the AI instantly adjusts. Speed and safety coexist, glowing together under the neon city lights. Seoul, South Korea, offers hyper-connected urban complexity. Neon storefronts glow as delivery drones zip between high-rise apartments. AI anticipates pedestrian patterns and traffic surges, rerouting vehicles before congestion even forms. Streets hum with life, synchronized by algorithms designed to maximize efficiency without compromising human safety. Jakarta, Indonesia, is bustling, unpredictable, and chaotic. But AI transforms these challenges into smooth flows. Maps continuously monitor street activity, rerouting autonomous vans around street markets, motorcycles, and sudden obstacles. Neon signage reflects on puddles, while vehicles glide through dense traffic, a visual demonstration of predictive intelligence, reducing congestion and delays. Manila, Philippines, has narrow streets and vibrant markets. Here, AI ensures real-time adaptive routing. Autonomous vehicles navigate alleys with precise timing, while neon reflections on wet roads highlight the seamless interaction of human and AI activity. Deliveries arrive faster, congestion is minimized, and safety is always a priority. New York City, the city that never sleeps, showcases AI at its peak. Times Square's neon billboards cast vibrant reflections as autonomous trucks and drones calculate optimal paths in milliseconds. Congestion hotspots are avoided, pedestrians and vehicles coexist safely, and deliveries are synchronized across boroughs. AI turns urban logistics into a glowing, perfectly orchestrated system. Guess what happens when split-second decisions matter? Imagine a delivery van in Durban encountering a sudden road closure. AI instantly recalculates the route, considering congestion, delivery priority, and pedestrian safety. Neon reflections streak past as if the city itself flows around the optimized path. This is intelligent urban choreography, where algorithms predict, adapt, and protect. In Santiago, Chile, AI handles sudden delivery surges. Multiple vehicles converge on busy streets, but routes are prioritized based on traffic, package urgency, and vehicle capacity. Streets remain smooth, congestion is minimized, and every delivery reaches its destination efficiently. Neon-lit streets reflect the precision of AI-guided motion. Tokyo's Shibuya crossing is a perfect example of extreme density. AI predicts pedestrian movement, splitting deliveries between drones, vans, and bikes. Neon advertisements flicker overhead as autonomous pods glide past crowds, showing that AI can manage even the most chaotic urban landscapes without delay or risk. Stockholm highlights environmental efficiency. Electric delivery vehicles dynamically reroute to avoid bottlenecks while conserving energy. Neon accents on streets emphasize smooth traffic flow, demonstrating how AI merges sustainability, efficiency, and futuristic aesthetics. Sydney illustrates predictive analytics in action. AI anticipates congestion on bridges, tunnels, and city arteries, rerouting vehicles preemptively. Autonomous trucks glide past neon reflections on the harbor, maintaining speed and reducing idle time. Here, optimization is both practical and cinematic. Seoul's high-density districts showcase real-time traffic management. Neon signs reflect off metallic delivery drones as AI reroutes vans instantly. Congestion is reduced, deliveries remain punctual, and the city moves like a living organism guided by predictive intelligence. Jakarta's busy streets show AI adaptability. Vehicles autonomously adjust to erratic traffic patterns, street vendors, and sudden motorbike swarms. Neon lights shimmer as autonomous vans flow through previously chaotic streets, minimizing idle time and delays. AI doesn't just navigate, it orchestrates urban efficiency. Manila demonstrates adaptive routing in extreme complexity. AI identifies bottlenecks in markets and alleys, splitting deliveries between autonomous vans and drones. Neon reflections illuminate wet roads as AI ensures packages reach their destinations quickly, safely, and efficiently. New York exemplifies global scalability. AI synchronizes delivery vehicles across boroughs, using predictive mapping to reduce congestion citywide. Neon billboards in Times Square aren't just aesthetic. They reflect an organized, efficient urban network orchestrated by algorithms. Guess what's next? Every city, from Durban to New York, Tokyo to Jakarta, becomes a shared network of AI learning. Algorithms refine delivery predictions, optimize routes in real time, and minimize congestion globally. Neon-lit streets aren't just beautiful. They're signals of a smart, efficient, ethical urban flow. Autonomous vans and drones continuously interact, recalculating routes, avoiding traffic before it forms, and completing deliveries with minimal energy. Neon reflections illustrate AI efficiency while highlighting human-centered design. Every city street becomes a glowing testament to optimized urban logistics. Efficiency isn't only about speed, it's about reducing congestion, improving safety, and optimizing energy use. From Durban's coastal roads to Manhattan's avenues, AI orchestrates deliveries with precision, ethics, and futuristic elegance. So here's the question. In a world where AI predicts congestion, optimizes every route, and guides every delivery vehicle through neon-lit streets, how much would you trust the intelligence behind the glow? Have you ever wondered what farming might look like if every tractor, every harvester, every irrigation system could think for itself? Imagine sprawling neon-lit landscapes, from the wheat fields of Kansas shimmering under digital auroras, to rice terraces in the glowing mountains of Vietnam, each stalk pulsing with faint neon light, orchestrated by AI that anticipates every need. In the plains outside São Paulo, Brazil, self-driving tractors glide through endless sugarcane fields, leaving trails of bioluminescent lines across the earth. Farmers watch from the edges, not in control, but as spectators to a silent ballet of precision and purpose. Meanwhile, autonomous harvesters in remote regions of Kenya navigate glowing savannas, identifying optimal crops and preserving fragile ecosystems, their neon headlights reflecting off the morning dew like electric brushstrokes. Across the Ganges Delta in India, irrigation drones hover above rice paddies, scanning for nutrient deficiencies while robotic harvesters hum through the night, powered by renewable energy grids. Holographic dashboards project glowing maps of each crop, each route, each microclimate, transforming ordinary fields into cyberpunk landscapes of living intelligence. In Dubai, vertical farms rise amidst the desert skyline, their glass walls glowing with neon hues. Inside, autonomous tractors trace perfect geometries over hydroponic crops while drones cast reflective light across the glowing soil. Here, futuristic technology meets arid landscapes, creating a neon oasis of sustainable agriculture. In Europe, vineyards in France and Italy have become luminous grids of AI-managed precision. Tractors trace perfect patterns along slopes, neon sensors monitoring grape ripeness, and drones casting reflective light over rows of vines. AI doesn't just follow instructions, it anticipates needs, adjusting irrigation and fertilizer in real time, creating a harmonious dance between technology and tradition. Even in extreme environments, AI thrives. In the arid expanses of Western Australia, autonomous machines cultivate drought-resistant wheat, leaving glowing tracks across ochre soil, while satellites beam data down to control centers in Sydney, coordinating irrigation, soil health, and harvest schedules with precision. And on the frozen plains of northern Canada, robotic harvesters operate under neon-lit auroras, navigating snow-dusted fields to optimize yield in harsh conditions where human presence is limited. But it's more than efficiency. It's about sustainability. AI-powered farms reduce waste, conserve water, and minimize environmental impact. In the neon glow of Tokyo's high-tech urban outskirts, vertical farms combine autonomous seeding and harvesting, with reflective surfaces bouncing soft, colorful light across layers of greens, herbs, and vegetables. Here, technology and nature coexist in a cyberpunk harmony, feeding millions without overburdening the land. Have you considered the moral compass of these machines? Every autonomous farm vehicle carries a set of programmed priorities. If a sudden storm threatens part of the field, should it save crops in one section at the expense of another? If an endangered species crosses a neon-lit irrigation canal in the plains of Kenya, should the tractor pause or proceed? Ethical decision-making, once reserved for humans, now extends into code, shaping the balance between productivity and preservation across continents. These ethical algorithms are evolving globally. Fleets of tractors in Argentina share data with rice paddies in Thailand, learning from each other's successes and mistakes. Imagine a tractor slowing autonomously when it detects workers near its path, its neon warning lights painting the soil red and gold, signaling caution before a human even realizes danger. Safety, efficiency, and ethics merge into a choreography that spans the globe under neon skies from Sao Paulo to Sydney. Society itself is transforming. Autonomous farm fleets can operate remotely, controlled from urban towers in megacities like New York, Berlin, Shanghai, or Dubai. Data streams from rural farms merge with city planning systems, predicting food supply, adjusting logistics, and informing policy decisions. The farm and the city, once separate, now pulse together as nodes in a luminous global network. Imagine a single crop cycle across continents. In the American Midwest, autonomous tractors seed with glowing geometric precision. In Japan, irrigation drones dance overhead in vertical farms, neon beams slicing through mist. In Kenya, pest management bots patrol savannas, tiny lights blinking like bioluminescent fireflies. Harvesters hum through the night in Argentina, their headlights casting ethereal reflections across dew-drenched fields. In Dubai, vertical farms hum with glowing machinery, while in Sydney, autonomous harvesters glide through coastal farmland, neon reflections painting the misty fields. Humans, freed from repetitive labor, become strategists and innovators. They monitor AI progress from city skyscrapers or remote farmhouses, reading holographic reports and experimenting with crop patterns, while machines execute with unmatched precision. Across continents, farmers are connected through neon-lit digital networks, collaborating in real time to solve global agricultural challenges. But with autonomy comes challenges. What happens when machines misinterpret data in Australia's arid plains, or a miscalculated irrigation in Vietnam? Trust becomes a global currency. Humans must learn to read machine behavior, anticipate algorithmic decisions, and intervene when necessary, all while respecting the autonomy of their robotic collaborators. As AI-driven machines spread, agriculture becomes a cultural spectacle. Fields transform into living cyberpunk canvases. Neon streaks across crops reflect city lights, from Cairo to London, painting glowing mosaics on the landscape. Even harvest festivals may feature choreographed drones, blending tradition with technology. Food itself tells a story through motion, light, and precision. Regulations will need to match innovation. Ethical frameworks for autonomous farming must evolve alongside machines. Should AI prioritize yield over environmental preservation? How do we measure its global impact on local communities, soil health, and biodiversity? These questions shape the next era of agriculture, a luminous collaboration of ethics, vision, and global connectivity. Technology will continue to evolve. Self-learning algorithms will adapt to weather patterns in California, soil shifts in South Africa, and crop diseases in India. Fleets of autonomous tractors in the Netherlands might share data with rice farms in Thailand, refining strategies across continents. The AI learns, adapts, and grows smarter, creating a network of glowing intelligence that spans the globe. The future of farming is not just about efficiency, it's about empathy, foresight, and balance. Autonomous systems must consider soil, air, people, and culture, making decisions that resonate worldwide. In doing so, agriculture becomes conscious and ethical, illuminated under neon skies that stretch from New York to Nairobi, Dubai to Sydney. Have you ever imagined witnessing a harvest orchestrated entirely by AI, spanning continents, under neon auroras and city glows? Watching machines that think, adapt, and care across diverse landscapes is mesmerizing, but it also reminds us the future is collaboration. Between humans, machines, and the glowing living world, decisions made in Kansas may echo in Tokyo, and strategies in Sydney or Dubai may inform fields in Argentina. In the end, self-driving farm vehicles are more than machines. They are partners, advisors, and stewards of global agriculture. Each glowing trail across a field, each hum of a drone, each neon pulse is a testament to a world where efficiency, sustainability, and imagination grow together everywhere from city outskirts to remote plains. So, as neon-lit horizons stretch across continents, consider this. In a world where AI can cultivate fields, optimize yield, and make ethical choices across diverse environments, how would you shape the role of human farmers? What decisions would you trust your machines to make, and where would you step in to guide them? Have you ever wondered what it would be like if humans could send their robotic counterparts into the most extreme environments on Earth and beyond, while staying safe behind the wheel of an AI car? Imagine standing on a rain-slicked neon street, feeling the hum of an AI car at your side, while watching humanoid robots tread carefully across the barren, rust-colored plains of Mars, their movements precise under alien skies, guided by mobile AI command centers. As we stand on the threshold of autonomous exploration, AI cars are evolving into more than just vehicles. Picture them as motherships, powerful, intelligent hubs, orchestrating fleets of humanoid robots through hazardous zones. These robots dive into the unknown, whether it's a crumbling city after a disaster, the crushing depths of the ocean, or Martian canyons bathed in the pale glow of distant suns. If you were nearby, you'd feel the subtle vibration of energy pulses as AI cars hum with life. Neon indicators reflecting off wet asphalt, scanning, calculating, and ensuring every movement is precise. What if a robot stumbles across a collapsed structure, unsure which path is safest? Here, the AI car becomes both guide and guardian. Advanced algorithms evaluate countless variables: structural integrity, oxygen levels, even subtle shifts in light patterns. Neon dashboards flicker with predictive models, sending precise instructions to the robot, every movement choreographed like a symphony. If you were standing just meters away, you'd see a holographic overlay painting safe paths in glowing neon lines, guiding the robot as if a visible hand were directing it. On Mars, dust storms swirl in iridescent reds and oranges, yet AI cars adapt in real time, rerouting humanoid explorers through safe corridors while maintaining a glowing, futuristic interface visible from kilometers away. Ethical decision-making becomes central to this vision. How should an AI decide between two paths that could endanger its robotic envoy? These split-second choices mirror the challenges we face with autonomous vehicles on Earth: avoiding pedestrians, calculating risk, anticipating chaos. AI empathy emerges here not as human emotion, but as a sophisticated understanding of consequences, visualized as a neon halo guiding each decision. Every movement, from a robot stepping across a Martian crevice to an AI car dodging debris in a flooded city street, reflects the silent intelligence of ethical coding. Imagine watching this unfold: a slight tilt of the robot, a guiding neon beam from the AI car, and you feel the invisible connection between human intent and machine precision. Humanoid robots offer a unique advantage: flexibility. On Earth, they explore sites humans cannot: volcanoes, radioactive zones, deep-sea vents. Picture a humanoid figure in cyberpunk-lit ruins, neon reflections glinting off damp metal surfaces, scanning every corner for structural weakness. If you were close, you'd hear the soft whir of servos, feel the cool rush of airflow from AI car turbines, and see light refracted across puddles as energy pulses connect machine to machine. The AI car, parked safely at the edge of chaos, becomes a silent sentinel, extending power and network support through wireless energy pulses, ensuring uninterrupted operation. On Mars, these robots traverse uncharted terrain, their movements mirrored by holographic projections within AI cars, glowing like neon constellations mapping the unknown. Coordination is critical. Imagine dozens of robots and AI cars working in unison. Each vehicle functions as a node, communicating instantaneously. Data streams flow in real time: topography, atmospheric conditions, potential hazards. Standing nearby, you'd sense the rhythmic hum of communication, almost like listening to the heartbeat of a futuristic city. The urban neon glow of Earth's cyberpunk skylines mirrors the digital pulse of Martian colonies, creating a bridge between worlds. Here, mobility meets cognition. AI cars aren't just transport. They're thinking hubs, capable of predictive navigation, crisis management, and dynamic decision-making. Consider a scenario where a humanoid robot encounters an unexpected collapse on a remote Earth bridge. The AI car calculates structural stress, reroutes energy to the robot, and overlays virtual paths for safe traversal, all while projecting subtle neon markers that guide visual sensors. Standing there, you might feel a slight warmth from the energy beams, see the robot's cautious steps illuminated in glowing lines, and sense the quiet confidence of an AI system anticipating danger. This same principle applies on Mars, where crevices hidden beneath red dust are revealed through AI-enhanced scanning, neon highlights illuminating the safest path forward. Every step, every calculation reinforces the symbiosis between AI cars and humanoid explorers. Safety and ethics intertwine. How do we teach autonomous systems to weigh risk without human presence? Imagine AI cars with ethical frameworks coded into their core. Each decision, whether on flooded streets or Martian cliffs, is logged, analyzed, and optimized. Neon lights pulse as feedback, providing a real-time visual representation of risk management, reflecting the AI's calculated empathy for the robotic life it protects. If you were observing, you'd sense the tension and relief in real time, like watching a silent guardian make life-preserving choices. The blend of ethical AI and hyper-realistic environments ensures not just survival, but responsible exploration. Humanoid robots are designed to extend our reach. Their dexterity allows manipulation of delicate equipment, retrieval of critical samples, and navigation of spaces too dangerous for humans. Visualize robots in neon-lit ruins, arms stretching into collapsed tunnels, while AI cars hover nearby like cyberpunk motherships, casting an ambient glow, constantly scanning for instability. Standing there, you'd feel awe, see light reflecting off every surface, hear the faint mechanical whispers of tireless intelligence. On Mars, this synergy becomes even more dramatic. Dust storms obscure the horizon, yet neon-guided energy networks keep the robots operational, transmitting every discovery back to AI command centers with remarkable precision. Imagine exploring a submerged alien city beneath Earth's oceans. Humanoid robots equipped with pressure-adaptive limbs navigate the deep neon bioluminescence reflecting in AI car sensors above, guiding movement with uncanny foresight. You might feel the chill of the water, see glowing life forms mirrored in robotic lenses, and sense the immense scale of environments humans cannot directly touch. This is the future of exploration. Cyberpunk aesthetics fused with hyper-realistic functionality. Every reflection, every movement, every calculated step creates a cinematic experience of intelligence and anticipation. The possibilities expand further. What if AI cars could dynamically adapt their positions, forming mobile hubs in orbiting colonies or extreme terrestrial environments? Robots on Mars could be deployed miles apart, yet linked through AI neural networks, moving like synchronized dancers beneath glimmering red skies. Data streams visualize in glowing graphs within AI vehicles, tracking progress, optimizing energy, and ensuring human-designed ethical guidelines remain intact. Cyberpunk realism ensures the world looks alive. The hum of neon-lit streets, the shimmer of holographic interfaces, the flowing movement of autonomous fleets. Every AI-human-robot interaction sparks reflection. How do we maintain trust? On Earth, humanoid robots navigating disaster zones require precise coordination with AI cars, demonstrating reliability. On Mars, ethical programming ensures that no robot is placed in undue risk, while AI cars orchestrate multi-robot expeditions with a glowing digital choreography. Watching this as a human, you'd feel both fascination and reassurance, seeing intelligence and safety fused together in every neon-lit movement. As we envision these futures, one thing becomes clear. AI cars are no longer mere vehicles. They are the minds, the guardians, and the coordinators of humanoid explorers. Their neon-lit interfaces, flowing data streams, and responsive intelligence create a bridge between imagination and tangible exploration. From Earth's glowing cyberpunk cities to the dusty horizons of Mars, these AI systems redefine mobility, ethics, and human ambition. So, the next time you imagine a robot stepping into the unknown, remember, it isn't alone. AI cars hover in the shadows, glowing softly with neon determination, orchestrating each movement, ensuring each choice aligns with a future where technology, ethics, and exploration coexist in dazzling harmony. What would you choose to explore first, Earth's hidden extremes or the uncharted mysteries of Mars? If a fleet of humanoid robots, guided by AI cars, could take you there,